All right, guys, let's slide into some friction. Okay, 4 questions. All right, these questions will show up again at the end. What are the two main frictional forces? A force between two surfaces that prevents those surfaces from sliding or slipping across each other. What is that called? Can you give an example of kinetic friction? And so always with concepts, like if you can give an example of it, that's a really great sign that you understand the concept. Arrange the forces of rolling, static, and sliding friction in increasing order. Okay, doesn't sound too bad. So we start off just with the types of friction. So just as far as just friction definition first, it's a surface force that opposes relative motion. The two main frictional forces that you need to be familiar with are static and kinetic friction. I believe that was one of our questions, was it not? The two main frictional forces, static and kinetic, right? If I was lining them up, those would be the two that I would want to make sure I had a good understanding of. Friction is involved in helping a moving car to brake, for example, keeping a runner from slipping, and even is needed when riding. So those are all examples that you could easily see on a test. Static friction is a force between two surfaces that prevents those surfaces from sliding or slipping across each other. Right? That was one of our questions. A form of static friction would be when your planted foot can grip the ground and push backward. Kinetic friction, our other important type of friction that we want to make sure we're familiar with. Kinetic friction always opposes the sliding motion and tries to reduce the speed at which the surfaces slide across each other. If you think of a baseball player sliding into a base, that is kinetic friction slowing him or her down. Static friction is directly proportional to the normal force, and it increases until the object begins to move. Kinetic friction is a constant, and it is less than or sometimes nearly equal to the maximum static friction. Still on the same thing, just want to make sure. Rolling friction must always be less than sliding friction, because in order for an object to roll, the force of friction between it and the surface must be large enough to keep the object from sliding. Static friction is more than sliding friction because the body needs to overcome the inertia of rest in static friction. In case of sliding friction, the body possesses inertia of motion since the body is already in motion. Okay, and then just a couple of examples here that can easily show up. So the horse harnessed to a cart, that's a common question for this topic. So in this case, horse is harnessed to a cart. If it exerts a force on the cart, then based on Newton's third law of motion, the cart must exert an equal and opposite force on the horse. For the horse to move with constant velocity, the frictional force acting on it being the horse, as well as the mechanical force it applies on the cart, need to balance each other out. Therefore, the force applied by the horse balances the force of friction. And that last sentence is really the key concept, right? That the force applied by the horse balances the force of friction. Okay, and then one other example, bicycle in motion. So when a bicycle is in motion, friction exerted by the ground on the two wheels is such that it acts in the backward direction on the front wheel and in the forward direction on the rear wheel. So you'd like to be familiar with that. The magnitude of the frictional force on the rear wheel can be greater than, less than, or equal to that of the front wheel. Okay, so that's a common example question. And then we come back to our 4 questions that we started with. So this is a great time to test yourself out and see if you can answer these questions.